Every so often, a single paper comes along and just changes everything. In 2017, a team at Google published something that didn't just improve AI, it completely rerouted its future. All the incredible AI tools we're using every day? Well, their story really begins here. Let's get into it.
And the title was just perfect. Almost a little cheeky, right? Attention is all you need. What a bold claim to make. But with that title, they introduced a totally new way of thinking about language called the Transformer architecture. This is basically ground zero for the AI boom we're living through right now.
But to really get why this was such a massive deal, we have to look at what was broken. What was the big problem that AI was stuck on before this paper dropped? Well, it all boiled down to one huge bottleneck. I like to call it the one word at a time problem. See, the top AI models back then, they had this very particular and painfully slow way of trying to understand language. Think about it like this. Imagine you're trying to read a really long, complicated sentence, but you can only read one word at a time, and you have to remember everything that came before just to make sense of it. That's exactly how the old models, like recurrent neural networks or RNNs, worked. The paper calls this an inherently sequential nature, and trust me, it was holding everything back. Okay, so this lays it all out perfectly. On the left, you've got the old way, this clunky word-by-word process that just fell apart with long sentences. And then on the right, boom, the Transformer's revolutionary idea. Why not just look at all the words at the same time? This was a game changer because it meant you could split up the work, making it way, way faster to train. And it could finally grasp the entire context of a sentence all at once. And that leads us right to the solution. The Transformer. This was a brand new architecture that, and this is a quote from the paper, completely dispenses with recurrence. In other words, it threw that whole one word at a time problem right out the window. All right, here it is, the original blueprint. Now, I know it looks a little intimidating, but the basic idea is actually pretty simple. You've got the encoder on the left. Its job is to read and understand whatever you give it. Then you have the decoder on the right, which creates the output. But the real magic, the secret sauce, it's all happening inside those boxes that say multi-head attention. Okay, so let's zoom in on that secret sauce. The engine that makes the whole transformer go is something called self-attention. This is the key. This is how the model finally broke free from that old, slow process and could suddenly see the whole sentence in a single glance. So the paper gets a bit technical, calling it a mechanism that relates different positions of a single sequence to compute a representation. But what does that really mean? Just think of it like this. It's a way for the model to look at a whole sentence and instantly figure out how every single word relates to every other word. Let's take a simple sentence. The cat sat on the mat and it was happy. So what does it refer to? The cat, right? Not the mat. Self-attention is what lets the model figure that out. It creates these direct links between all the words, no matter how far apart they are, and then it calculates an attention score to figure out which links matter the most for context. So the basic building block for this is called scaled dot product attention, which you see on the left. But here's where it gets really clever. They didn't just do it once. No, they created multi-head attention on the right. This means it runs the same process over and over again in parallel. The original paper used 8 heads. It's kind of like having 8 experts read the same sentence at the same time. One might look for grammar, another for who's doing what, and all together, they give the model this really deep, layered understanding. Super cool. Okay, so the theory is really neat, right? But the big question is, does it actually work better? Well, the researchers didn't just leave it at that. They brought the receipts with some really compelling data. This table, pulled right from the paper, is pretty much the smoking gun. Just look at those 2 columns, sequential operations and maximum path length. For the older models, the numbers depend on n. That's the length of the sentence. So the longer the sentence, the harder they have to work. But look at self-attention. It's O of 1. Constant. That's huge. It means the model can connect the first word and the last word of a sentence just as easily, whether the sentence has 10 words or 1,000. The distance just doesn't matter anymore. And that right there spells out the massive advantages. That constant path length means the model doesn't get lost in long, complex sentences anymore. And because it's so easy to parallelize, you can throw a bunch of powerful GPUs at it and train these things incredibly fast. Honestly, this efficiency is the only reason we have the giant AI models we have today. It was a total breakthrough in both power and speed. So a cool theory and some impressive numbers are great, But at the end of the day, it's all about the results. And let me tell you, the Transformer didn't just do well, it absolutely demolished the old records.
Back then, the big test for machine translation was this specific English to German task. The Transformer scored a 28.4 blue score. Now, a blue score is just a way of measuring how good a machine's translation is compared to a human's. And in this world, people fight tooth and nail for every single decimal point. So 28.4 might not sound like a huge number to you or me, but you have to understand, in this space, progress was measured in tiny little fractions of a point. To come in and beat the best score by over 2 whole points, that was absolutely unheard of. It wasn't just an improvement, it was a revolution. And get this is the best part. Not only was it better, it was also ridiculously fast to train. They got this record-breaking result in just 3.5 days using only 8 GPUs. That was a tiny fraction of the time and money it took for the older models. I mean, this table just puts it all in perspective. The Transformer gets the best scores on both tests, and look at the training cost. It's way, way lower. It's the classic better results for less money story. You just can't beat that. So you had better results, you could get them faster, and it costs less to do it. Better, faster, cheaper. That was the trifecta everyone had been searching for. The moment this paper was published, that was it. The starting gun for the AI revolution had just been fired. So why are we still talking about a paper from 2017? Because pretty much every single large language model you've ever heard of, yeah, ChatGPT, Claude, you name it, is built using this exact same architecture. You know GPT? The T literally stands for Transformer. This paper didn't just give us a better model, it gave the whole world a new instruction manual for how to build intelligence. The authors made that incredibly bold claim, attention is all you need. And you know what? For the last several years, they've basically been proven right. It really makes you wonder, though, as we keep pushing AI further and further, if attention was all we needed then, what's the next big thing we're going to need?